Hi everyone, and welcome to my next video tutorial, which is going to be focused on containerizing a Django application and also deploying it, right? So let's get started. Now, I'm not going to take a deep dive into the Docker fundamentals per se. I am going to give a bit of a brief overview in terms of the Docker fundamentals, and then we're also going to majorly focus on how we can containerize and deploy our Django applications as the focus. However, as a deep dive, I do have a full crash course on Docker here on my other channel called Cloud Native here, and that's going to give you a deeper dive if you want to look at the core fundamentals of Docker itself. All right, so just something I want to mention just so that you are aware. Now, in this course, we are going to specifically look at how we can build a Docker file, how we can utilize a dockerignore file, how we can build our Docker images, how we can transform them to be ran as Docker containers, and also how we can go on ahead and utilize Docker Compose and go from that point onwards. And then, of course, we'll focus more on the deployment side and all of the rest in terms of the aspects for deployment. All right, guys, so that's just a bit of an introduction as to what to expect and how to get started. All right, now all of the necessary links and references that I use in this video, including the video that I mentioned earlier on and the Docker desktop website here, I will be sure to add in the description below, so do keep that in mind. All right, now one last thing before we get started, I just have a brief announcement to make. So let's just go on ahead and look through that. All right, so I just want to give a very big thank you and a big shout out to JP for deciding to support Cloud with Django on my Ko-Fi page. Thank you so much for support. It is greatly appreciated. Thank you again, JP. All right, so let's get started. Now, the first thing that you're going to need, of course, is a Django project that you want to work with. So I have one here up and running that I want to apply with. So make sure you've got that in place. Okay, now the next thing I want to mention here is that you're going to need the Docker desktop app on your device. So if you head on to the following page here at docker.com/products/docker-desktop, I will put the link in the description below for you to navigate quickly to that site. This is going to be the official site for installing Docker Desktop, which is the application that we're going to use to Dockerize our applications. Now you want to scroll down, and what you're going to want to do is to download Docker Desktop. So now you can see here there are various options available. So if you have Windows or Mac on the Intel chip or the Apple Silicon chip, or even Linux, you can download it for your respective operating system. So all you need to do is download it for your operating system, and after that point you can go on ahead and set things up. Now, just a little bit of insight in terms of those that may be confused with Intel chip and Apple Silicon chip. So essentially speaking, the M series chips on the new Mac OS devices will be Apple Silicon, and usually the older chips, if you have an older Mac, you'll utilize the Intel chip. So just a little bit of emphasis on there in terms of the M series chips. Okay, so make sure you've gone ahead and downloaded that, very important. After you've done so, you can then navigate to your application that you want to use, and the first thing that you're going to want to do is to ensure that you have a requirements.txt file in your directory. So as you can see here, I don't have one at this moment. I just have a Django project called Elevate, and I have a Django app called CRM, and of course SQLite database for now. So I'm going to open up my terminal. So if you are on the macOS terminal, just a quick command I want to mention. If you want to clear your terminal on Windows, you'll say CLS. On Mac, you'll say clear. So that's just something I want to mention. So as you can see here, that we're using Windows, so that won't be the case. Okay, so I'm in my directory now, and the first thing you want to do is say pip freeze greater than requirements.txt. And that's going to freeze all of your dependencies into a requirements.txt file. All right, it will indent on a new line. And now if I go to my requirements.txt file, I can see all of the relevant packages here in place for me. All right, so make sure you've gone ahead and run that command. Now that's important for Docker so that it has the relevant instructions to install all of the packages into your Docker image eventually. Okay. Next thing that we're going to do is to create a Docker file within our directory here. Now, before we do that, let's just have a brief understanding of what Docker is. Now, Docker is essentially a platform that allows us as developers to package our applications and their dependencies and even runtime into a lightweight portable container. And these containers are going to ensure that our applications run consistently across different environments. So we don't have this issue of it works on my PC, but not on his or her PC. Okay, that sort of situation is what Docker basically solves in a nutshell. Okay, so to get started with all of that, we want to create a Docker file. So in our directory here, just zoom in a tad bit, I'm going to go ahead and click on my main project directory here, which is called Elevate. I'm going to say new file, and I'm going to call this Docker file. Okay, there we have it. Okay, we can close that. And now let's go on ahead and get started with the necessary commands. So a Docker file is essentially a script that contains a set of instructions to build a Docker image. And it's going to define, in this case, what I just mentioned earlier on, our environment, dependencies, configurations, anything that we need to run an application that we want to utilize. All right, so let's get started and create our Docker file. Okay, now the first thing that we're going to want to do is we're going to want to utilize the official Python image as our base. So you can navigate to a site known as hub.docker.com, or commonly referred to as Docker Hub. And here you can search for Docker-based images for certain, how can I say, software. So I'm going to say Python, for example. And here we can see we have Python. Okay, so here's Python, for example, and we can just go ahead and pull the official Docker image for Python, since we are utilizing Django, which is based on a Python-based framework. Okay, now there are specific versions that you can also utilize here, denoted by various tags, as we can see here, such as Bookworm, Alpine, etc. And you can see it starts off by referencing the current Python version first, and each of these tags have their own unique lists of, how can I say, benefits and limitations, of course. So each of them have their own sort of ways of going about them. Now, usually the slim version of each category here is going to be a lot faster in terms of setting up and organizing everything effectively. Now, you can technically just directly pull the base Python Docker image here. However, it is good practice when you're using Docker to utilize a specific version here that is available for you. Now, you can decide what one is going to be appropriate based on the Python version that you're using. But what I'm going to do is I'm going to choose a specific version that is available here in terms of the tag. And I'm going to use 3.12 as an example, and I'm going to use a slim version, so a little bit simplified. So here I see I have 3.12.9-slim-bookworm. So this is going to be my tag that I want to utilize here. So I'm going to say from, okay, then I'm going to say Python, and Python is in direct reference here to the Python official Docker image. And then after the colon, you can either put in the Python version, like the base version you want to use. So if you're using 3.12, 3.10, 3.13, etc., or you can use a specific version here in terms of the category, which I'm exactly going to do. And I'm going to use 3.12.9-slim-bookworm. So I'm going to say 3.12.9 and then -slim-book1. So I just want to correlate that that's correct. There we go. Yeah, we're good to go there. Okay, perfect. Next slide. Next thing we want to do is we want to set environment variables to prevent the creation of PyCache and to also enable output buffering. So to do so, we need to be very careful with how we declare it. So I'm going to say env, and then I'm going to say Python. Okay, then you want to say don't. Then you want to say write. Then you want to say byte code equals 1. Okay, so it's just make sure you type it correctly. So Python, then we have, of course, don't, write, byte code equals 1. Then we're going to say env, then we'll have Python buffered equals 1. Right. Great. Now, the next thing that we want to do is we want to set the working directory inside the container which we're going to create. So we're going to say work dir / and then you can give it any name that you feel is necessary. So I'm going to call this app. So this will just be a directory inside the container that we're going to work with. So this is where we're going to essentially install all the dependencies to essentially copy our project directory into as well, and all of that. Okay. Next thing that we want to do is we want to copy the requirements.txt file into our container. Now, this is why it's important that you have a requirements.txt file in your directory so that we can refer to it. So here I'm going to say copy requirements.txt. So that's going to ensure that that is in our base directory, which it is. Right, so let me zoom out here so you can just see a bit clearer. Next thing that we're going to do is we want to upgrade pip and install our dependencies from our requirements.txt file. So in the next line, we want to first upgrade pip. So I'm going to say run pip install -- upgrade pip. So this is a notice that always comes up. Next, I want to actually install my dependencies from my requirements.txt file that I've just copied over. So I can say run pip install -r requirements.txt. Then I want to copy the entire project directory into the container. So I want to copy all of this into my container, which essentially is going to be /app. Okay, and you can say copy dot and dot. So we're copying everything from our base directory to our app, which is essentially going to correlate to this dot here that we have at the end. Right, so here is the full Docker file here for reference if you just want to skip over as to what we have so far. Still have 2 more things we need to do, but make sure you've got this as it is. Right, next we need to expose our port to allow access to our application. So I'm going to say expose port 8000. And finally, we want to define the command to start our Django development server. So you can say cmd, and then here within square brackets, we're going to say Python, comma, then we're going to have manage.py, comma, then we're going to have run server, and then we'll have 0.0.0.0 at, and we're going to map that at port 8000. Okay, so this is going to help start our server. So that is the full Docker file in its totality. So we want to ensure that we import and utilize the base Python image, utilizing the Slim Bookworm category. Okay, then of course we want to prevent creation of the PyCache and to enable output buffering, set up our work directory that will be within our container. We want to copy our requirements.txt file, and we then want to install all the requirements, all the dependencies within that file, upgrade pip. We want to then copy everything into our container, namely into app. We want to expose our port here on port 8000 for listening, and then these are the set of commands that we need to execute to get this Docker image to essentially be utilized when we have created it. Great, well done. So that is what we need to do. Okay, great. Now that we have this Docker file, as you can see in our directory here, we now want to create a dockerignore file. So what you can do is click on your base directory of your Django project, say add new file, and you can say .dockerignore. Okay, right, so in this file what we want to do is we want to tell Docker which files and directories should be excluded from the image build process. And this is going to help to reduce the image size, and it's also going to help to improve security by preventing any unnecessary file from being copied and such. Okay, so let's go on ahead and set that up. All right, now in my case, my virtual environment, as you can see, is well outside the build context for our Docker file when we are essentially building our application here. Now, for those that have the environment variables or a .env file within the current directory here, this is what you would do in your Docker file. You would go on ahead and say .env, or if you have that virtual environment directory within that context area, you may also have venv /. Now, it would be also best to ignore your Docker file itself here to avoid any unnecessary copying. So I would say Docker file. And then if you are on macOS, I believe there is something known as the DS store. So you can have .ds underscore store. If you are on macOS, you'll include that as well. Okay, so .env, that's going to prevent any sensitive environment variables from being included. This venv /, that's going to exclude the local environment variable that you might have in your build context. And then we want to avoid copying the Docker file into the image itself here. And then, of course, the .ds store, if you're on macOS, is to exclude the macOS system generated files. Okay, so I'm on Windows, so I won't need this. And of course, my virtual environment and such is outside. So I'll just have the Docker file itself. All right, so we've got that set up. Great. Now, the next thing that we want to do is we actually want to learn how we can build our Docker image. Now, before we do that, what we need to do is ensure that Docker desktop is up and running. So what I'm going to do is just minimize here, and we can just look for Docker desktop, and I'm going to open that up. Okay, so let's just give that a moment to load up. Okay, and once it has loaded up, we can then go ahead and continue. All right, so let's go on ahead now and build our Docker image. Okay, so we can see now that Docker desktop here is available. So we can see we have our list of images, any volumes that we may have, and our containers. So first, let's go ahead and create our Docker image. So I'm just going to move this right here. And what we can do is open up our terminal or wherever we are coding within. And you want to write the following command. So you'll start off by saying docker build. And docker build is going to start the build process for us. Then you want to have -t, which stands for a tag. And then we want to utilize this prefix here to assign the name of our Docker image to the built image. And here you can give it any name that you wish. I'm going to call mine docker-image. You can call this anything that you want. And then you want to add a space and dot, and the dot is going to specify that the Docker file is in our current directory, which as we can see it is, there it is, Docker file. Okay, so we have that set up, and then you want to press enter. And that's going to then start the build process. As we can see, it's going to fetch that metadata from our base Python image, which is 3.12.9 at Slim Bookworm. And of course, it's going to fetch that image first, and then you'll notice as you look at the logs here, it's essentially going to follow all the commands that we went ahead and specified. As we can see here, we can see we went ahead and set up the environment accordingly. We set up our work directory that we want to copy all the dependencies that are part of our requirements.txt file, upgrade pip, install those dependencies, copy everything from our directory into this app directory, which will now be available within the container that we're going to set, expose our port and the lot. You'll notice that a lot of that will be right here in the logs as they are being completed. So you can see here, for example, as I mentioned, the work directory command, the copying requirements.txt, upgrading pip, installing all the packages, and copying everything into an image, which is just about set up to be exported. So we just need to wait for that to be completed. Then we can go ahead and continue from that point. Right. All right, so let's head on back to our terminal, and we can see now that our image has been exported here, as we can see, and we have some information in terms of the build details. Great. So as a confirmation, you can head on over to Docker Desktop, and here we can see we have our Docker image that was created. We can see some information in terms of the name. So remember, when we use docker build-t for tag, we tag the name as docker-image. The associated is latest. We have an image ID here set up when it was created, and we can also see the size of this Docker image. So very well done. You have successfully gone ahead and built a Docker image based on your Django application. Now, I just want to show you another command as well. If you head on over to your terminal, you can also type in Docker images, and that's going to output the list of all of the Docker images that are a part of your Docker desktop app here. So we can see the name of the Docker image, the jag, the image ID when it was created, and the size. All of this information is also reflected, as we can see here, under Docker images. Right, so well done. Now that we've done that, what we want to do now is we want to essentially go on ahead and run a Docker container. So we can head on over to our prompt, clear this up, and please make sure that you have a Docker image before continuing, because remember, a Docker container essentially is part of a Docker image. It's essentially a Docker image that has been transformed to run as a Docker container. So just remember to keep that logic in mind. Okay, right. So the command is as follows. We want to say docker run, and that is the command that you will use to start a new container. Okay, then you want to have the flag of -d. Okay, this is going to run the container in detached mode in the background. So that means that you won't see all of those logs here in this terminal. Okay, it's going to run in the background. This is very helpful because if you don't do this, it's going to show all of the logs in your command prompt. And there are more effective ways of managing logs, because you won't be able to utilize your terminal anymore because everything's going to run right here. Okay, next you want to specify the name of your Docker container, and to do so you need to explicitly use the name flag. So you would say --name, and then the name that you want to assign your Docker container, I'll just call mine docker-container. Okay, great. And the next thing you're going to want to do is you're going to want to now go on ahead and set the port. So we want to map the port inside the container. So you want to say -p. Okay, and you're first going to ensure that you set up your ports accordingly. So you want to map your host port to your container port. So I'm going to set that as 8000 to 8000. Okay, then what we want to do is add a space, and then it's going to go to the new line, and you want to specify the image that you want to transform as a Docker container. So I'll say docker-image. Okay, so let's maximize that. So we'll have Docker image at the last part there. Okay, so this is the command that you use for running a Docker container. Right, we can then press enter. Okay, as you can see now, it is now running, and you can see the ID that was generated for that particular Docker container. So now if we head on to images, we can now see this green icon here in Docker Desktop that it is in use, and that means it will have been attached to a running Docker container, which we can see the name, docker-container, we can see the ID, we can see which image it is linked to, and we can also see the port that has been mapped. So it will be available on our device at port 8000. Okay, so let's go on ahead and click on that link there, and there we go. We can now see our application. So an interesting thing to note here is what I can do is I can go to my command prompt now, and I can say python manage.py run server, for example. Okay, let's run that. Okay, there we go. And you can see here on our default localhost 127 mapped to port 8000, this is our regular Django application that we're using. And here is our Dockerized Django application running as a container. So you can see here that we have that difference here. So very well done. You have successfully now learned how to containerize your Django application to transform your Docker image to run as a Docker container. So do keep in mind here the changes that we do have. Okay, so very well done on getting to this stage. Now, a very cool command that you can also utilize is if you head onto your command prompt, you can stop your server from running, and you can go ahead and say docker, okay, and you can say ps, and that's going to list all of your Docker containers that are currently running. So we can see we have the following details in place here. We can see the container ID and the ports. We can see the image. We can see the command and the name that we use when it was created, the status if it's up and running, and we can also see that we are mapping accordingly on the host port, which is of course on 8000, to our container port on 8000. Now it's good practice in Docker to ensure that your host and your container port that you bind, so for example, here we can see 8000 to 8000. So both the host and the container port are mapping on the same port. Some people I know, of course, like to set the port to, for example, 8080 to 8000 or 8001 to 8000. Now, that's perfectly fine. You can do that, but it's best practice with Docker to make sure that both of the ports are matching. Okay, it just makes things easier in the environment that you're working with. All right, so we've learned now how to build our Docker image and how to transform it to run as a container. The next thing that I want to look at is Docker volumes. So that is something that we're going to take a look at and see how we can utilize it. Right, so Docker volumes. A Docker volume is useful if we want to persist data between our container restarts. And this allows our application to update files without needing to rebuild the entire image. So let me show you what I mean in terms of persisting data. Right, so I just want to go on ahead and just run my Python application like normal. Remember, our container is still running. So do keep that in mind because we built it in detached mode. Okay, so localhost here, mapped to 8000. This is our container that's currently running. And the reason I just started the server here is just for my regular Django application, which as we can see is at 127 mapped to port 8000 right here. Okay, so both of them are the same. Okay, and it's got the same code that was built in earlier on when we went ahead and set up the Docker image. Now, let's say for argument's sake, in this application that I have, I go and change some code on the index.html page. So let's say, for example, at the bottom, just add in a breakpoint and I say this website was made by Arno. Okay, so I'm just adding in that change there. And let's say I go to my website now and we can see the server's running and I just refresh. You can see it says this website was made by Arno. But if we look at our Containerise application and I refresh here, you're going to see that it doesn't reflect that change. So that is where Docker volumes can be very useful. Okay, and what we want to essentially do is we want to use this Docker volume so we don't have to constantly delete our Docker image that we have and then to rebuild the container and to keep on doing the process again and again. This can be really tedious. So the first thing that we want to do to set up our Docker volume, of course, is just to stop the container and then transform this Docker container now to also set up a Docker volume. Now you can stop and delete the Docker container here in the UI here by selecting it by the checkbox, and you can say stop and then delete, or you can just go on ahead and delete. However, it's best practice to rather say stop then delete. Or what you can do is you can stop it and then you can utilize the delete icon here in the UI. Now, if you wanted to apply that same logic to the terminal, you can head onto your terminal, and what you want to do, we can just stop this for now, and you can just say Docker, and then you want to say stop, and then you want to refer to the Docker container that you want to stop. Now you can refer to the name that we have here, and it's called Docker-container. Very simple. So what you can do is say Docker stop, Docker-container, so the name of your container, and enter. Okay, it's going to output the name there, and if you head on now to our list of containers, you can see it's no longer in green. It has now been stopped. And now you can go ahead and delete your Docker container. Now to do so in the terminal, you can say Docker rm for remove, and then you can just say Docker container. And it's going to output the name of it again. And now if we head on to Docker desktop, we can now see it has been deleted. Okay, so just a few ways in which you can go ahead and set things up. Okay, now let's say for argument's sake, I now want to set up my Docker volume. We want to head on over to our terminal and we just want to extend onto that command that we set up earlier on. So to do so, we would need to first write the bread and butter commands for setting up a Docker container first of all. So you can say Docker run -d in detached mode, --name, give it a name. I'm going to call this Docker-container. And then, this is very important, this is where the volume part comes in. We want to add in the tag -v, okay, that's going to be for volume. And then we want to mount our current directory to the app directory inside our container. So to do so, what you want to do is say dot, that's our current directory, add the colon, which means map, and then where to our container's app directory. So remember, this app directory is what we specified. If I show you here in the Docker file, so remember, we specified it as app here. Okay, so we're going to ensure that anything changed in the application, which is signified by dot in our application, is reflected within the container directory as well. Okay, so it's going to mount the current directory dot to the /app directory inside the container. And that's going to ensure that any changes that are made to files in our local directory are reflected inside the container itself. Okay, and the last thing you want to do is just go ahead and say -p and then space, and we're going to map the host and container port. So you'll say 8000 and map it to 8000. Okay, and then you want to specify the Docker image that you want to transform as the container. So remember the name that we specified here, which is docker-image. So you'll just say docker-image and enter. So there we go, it's set up. So now what's happened is it's gone ahead and set up our container and also added in the necessary Docker volume. So we can head on back to images. We can now see that that image is now in use and it's now been attached to this container. Okay, we've got all of the basics set up and into place, and we'll get to the volume section in a moment here, but we can see that we have set this up and organized it to now have a Docker volume in place. Okay, so now what we can do is let's head on over to our application. So this is localhost. Okay, this is where our container is running. We can refresh that, and you can see now it says this website was made by Arno, and that's exactly what we had before. So now let's go ahead and test this real time. So let me run my server. Okay. Okay, and okay, let's just refresh my normal application and my Dockerized application. You can see now that it took that change now, and we didn't have to rebuild our Docker image or anything of the like. Right, now let's say, for example, go to index.html again, and what I want to do now is just add in a line here and say h4 or. And I'm going to add a HR, so a line there as well. Let's go to my regular application, because remember, I do have my standard Django application running. And now I have OR here. It's quite a long line underneath. Let's take that out. Okay, so there we have what we have set here. Let's go to localhost, our containerized application. Let's refresh. And we can now see that that change has been reflected now within our application here. So this is a very useful case, as you can see, for our Docker volume. We can see that that data, in terms of the changes we made, have persisted. I didn't have to manually go on ahead and make adjustments with my image to rebuild the image and to start the whole process all again. Okay, so you can see here the usefulness of utilizing a Docker volume. Right, so that's just something I wanted to mention here. Very important and very effective to use your Docker volumes if you want to persist data made to your application between any sort of container restarts or anything of the like. All right, so that is Docker volumes and how we can apply it to our Django applications. Now, the next thing I want to focus upon is a Docker compose file. Now, you saw those commands that we were utilizing. It can be quite tedious to constantly have to run these very long commands. We can instead use a Docker compose file to simplify this. Now, our Docker compose file is going to help us to define and manage multi-container Docker applications, and it can also allow us to configure our services, any networks and volumes in a very simple YAML file. Okay, so that's what we're going to look into next. Okay, so what we can do now is we can head on over to the Docker Desktop UI, and this time what I'm going to show you is how to do it in the UI. You can click on the checkbox here, then you can say stop selected items. That's going to stop your Docker container, and make sure you still have it selected. You can then say delete, and that's going to delete that container for you. Right, there we have it. All right, so there we have it. Next thing we're going to look at is Docker compose. All right, so let's get started with our Docker compose file. So in our directory here, we just select my project, and I'm going to say new file, and this will be known as docker-compose, and it will be a YAML file, so you'll have .yml. There we go. So this is our Docker compose file. Okay, so let's get started. Now, the first thing that we want to do is name this Docker project. So when you start with any Docker Compose file, you need to name your Docker project. So at the top, we want to say name, colon, and then give a name to your Docker project. So I'm just going to call it Docker project, very simple. Next thing you want to do is define your application services. Now, with the services, you will typically have your app. You would also have, for example, a database. You may also have additional services such as Redis, Celery, etc. But in our case, we just have the application for now. So we want to define our services. Okay, and the service that we do have of this moment is our app or our application. So you want to press enter, and then you just want to add in a space here, okay, and another one. So 2 spaces, and then we can say app, and that is going to define our application. Then the next thing you want to do is press enter, add a space here, and then you can say image, and we want to specify our Docker image that we want to utilize. So our Docker image is going to be called docker-image. Then we want to specify the container name. So here we're going to say container_name, and I'm going to call this Docker container. Then we'll have the port. So we're going to ensure that it is as follows. So we'll add a space, dash, space, and we're mapping the host port to our container port on ports 8000. Then we want to specify the volume. Now remember, space is important here, and indentation. So we will have volumes, colon, and then we want to set it as dot. As in our current directory, you want to ensure all changes from our current directory are mapped to our containers directory, which is at /app. And that is all that we need here. Okay, so remember what we're doing here at the end is we're mounting the current directory to /app. We're mapping the host to the container ports. And that is what we have. That's all we need for a basic Docker Compose file. Now, before we go ahead and run this, what we can also do is delete the current image that we have. So if we go to the UI, we can see here under images, we have this image. You can click on this and you can say delete and delete forever. There we go. So the image is also delete. Now, a useful trick that I also want to teach you before we run our Docker Compose file is how to clear your cache. So we can stop our server and you can say docker system prune. And that's going to remove all stop containers, all networks that have been used, all dangling images, and any unused build cache. So the whole idea with Docker images, if you want to rebuild your Docker images, which you can do, of course, what happens is it usually caches the files that you've used before. So the process for building Docker images will become faster each time you run the docker build command for your image. However, what will happen is any code that is unchanged will be cached. That's the reason why it will be a lot faster. Now, what I always recommend that people do is always to clear their cache, especially if they're doing a fresh build, because sometimes there can be issues now and then depending on your requirements. So I'll add Y, and that's going to take some time depending on how big the cache was. So you can see here all the reclaimed space and all the cache objects that have been deleted. So just a useful function that I like to do when after I've deleted the containers and the images and volumes, etc., it is essentially going to be removed. Right, so let's navigate back. Now, if we have a Docker image that is already set up and ready to go, we can simply go ahead and just say docker compose and add in up and then -d. Now, we're not going to do that yet because remember, we don't have a Docker image. Now, if you have a Docker image, and you want to just transform it to run as a container, and you have the following code, you can simply run docker compose, and then you're just going to say up-d, okay, if you have a Docker image. If, however, you don't have a Docker image, you're going to want to add in the following flag, which is build. But before we can go on ahead and utilize build, we're going to want to ensure that we have that statement here in Docker Compose. Okay, so we need to add in a build phase. Okay, and that's going to be just below the app part here. So what I'm going to do is just say enter, and we're going to want to indent just a tad bit here. So we can see here that we have the following. So we have our container name, our image, and everything here set. And what you want to do is you want to say build, colon, and this specifies that Docker Compose should build the image instead of pulling it from a registry. Enter, and then you want to just go ahead and indent 2 spaces, and we can say context, colon, and then dot. So that's going to be from the directory where our Docker file is located, so in our base directory. And then you want to say Docker file, and you want to grab the Docker file that you're working with. Now the name of it in my case is just Docker file. So you would just say outside Docker file. So that's the Docker file we want to use. Okay, now with this addition here, this is going to allow us to build our Docker image as well as also run it. Okay, so now we can head on over to the command prompt and we can say Docker compose. Okay, and you want to go ahead and say up, then you want to have -d, and then at the end you want to have --build. Now again, remember what I said, if you have a Docker image already, you don't need to add in the --build flag, and you don't need to add in this part of code. Okay, if you already have a Docker image that you're working with. Okay, then we can say enter. That's going to build it based on the instructions that we set up in our Docker file. So we can see it's running. Now it's going to take some time to build our Docker image, then it will transpose into a Docker container. And in terms of what I mentioned earlier with how we can ensure that we are able to change our Docker Compose file for just running containers, that is something that we're also going to look into. All right, so let's just give it some time for this process to be completed. All right, so welcome back. So as you can see, our Docker image was created and we can verify that. You can see there it is available. It's also in use. And we can see that is because we have gone ahead and set up our Docker container. So you can see the name is called Docker project because that's the name of the project that we've specified here. And if you click on this drop down arrow, it's going to show the Docker container that was also created that's attached to our Docker image. And you can see here that it says that the app was built. We've also set up a default network and our container has started and it's in the running phase. So we can see everything was set up. So well done. That's how you can utilize a Docker Compose file to essentially go on ahead and build your Docker image and then straight after transform it to run as a Docker container. Okay, we also added in volume so we can actually do some checking as well. So let's go on ahead and head on to our application and let's just stop this. Let's just run our server normally. Okay, and let's just see what it is like now. Okay, it's fine. Now let's do the test. Let me change something. Okay, let me go to index.html. And let's see, we can move that line just below, I would say. So let's take this horizontal line. And I'm going to put it right here at the bottom, save that. And now on my regular Django application development server, I'll reload and we can now see it's at the bottom, this line now. Let's go to our containerized application. It should also have changed. So let me reload the page and you can see it has changed. So we can see we also have that volume in place, which is being read from our Docker Compose file here to just notify it to us that the data will be persisted. All right, so well done. Now the next thing I want to show you is what I mentioned earlier on. So remember we added in the build flag with the Docker Compose up command. Now let's say for argument's sake that we don't have a Docker file that we want to utilize or anything of the like, because a Docker image, because we already have a Docker image. So I'll show you how to do that as well. So what you can do is you can just go ahead and click on the following icons here, and we can just stop this Docker container. Okay, so it's going to take a moment to stop. There we go. Then we can also delete it. And there we go. Right. Okay, so let's go ahead and do this now that we just have a Docker image to utilize. So let's go ahead and speed the process up now. Let's do just that. Right, so what you would need to do is you can just go ahead and remove this code, or you can even comment it out. So I'm just going to remove that. Okay, so we are where we were before. Save that file. And now with this code, okay, we don't need to build anything or give in the build instruction or anything of the like. All right, now what I'd recommend you do is also to just ensure that everything's in place and indented nicely. And you can head on back to your terminal and you can just say docker compose, okay, and then you want to say up-d in detach mode, and that's going to take that Docker image that you already have and it's going to transform it into a Docker container for you. So if we go back, we can see that image now is in use that we had before, and we can now see that it's gone ahead and been set up to run as a Docker container for us, and we can see that that is as it was before, perfectly fine. And we can just do another simple test for the volumes. So I'm just going to say, I like this website. Okay, just something random, just for testing. Let's run our server now. Okay, let's go back and let's reload. It says I like this website. Let's see if that took effect with the containerization, with the volume, and it took effect. Great. All right, guys, so there we have it. That's how you can utilize your Docker Compose file and how you can run your container with the code necessary, as we can see here, just for taking an existing image and then transforming it as a Docker container, or like we had before, you can add in the following logic if you want to set it up in such a fashion that you are able to build that image from scratch and also run it as a Docker container. All right, so there we have it. That is the fundamentals in terms of containerizing a Django application. We're now going to move to how we can utilize Postgres and then move on to the deployment phase. So what we're going to do now is we're just going to clean everything up that we have. So first of all, let's stop our Docker containers and let's click here and say stop. Okay, and we can delete this. Go to images, we can select that, and we can delete that. Let's clear our cache now, so let's stop our server. We can say docker system prune. Going to clear all the cache that we have. There we go. And we are good for now. All right, so there we have it. We are going to make some adjustments into what we have set up and everything, but this is the fundamentals as we are learning to containerize and then to deploy. All right, now the next thing that we want to do is we want to containerize a Postgres database. And this can be very useful in testing and local development, and I'll show you just why. Okay, so again, we're going to go to our Docker Compose file. And what I'm going to do is just zoom out a tad bit, just so you can see the whole structure clearly. Now, as you can see here under services, we've defined an app. Now, this is namely the logic that we need to Dockerize our Django application, but let's say we want to Dockerize a Postgres database. So it's going to be a service and it will be a database. So what we can do is press enter, and here in line where you see app, you're going to put DB. Okay, so this is going to be the main point here for setting up our Postgres database. So we want to specify that this is going to be the DB logic, and you want to add in a colon at the end. Right, on the next line, you want to press enter and then just make sure you add in a space. And here, what we want to do now is we want to specify the image. So we're going to say image and then colon, and then you want to specify your Docker image. Now, when we specify image here, we can either put in the name of that we want of the Docker image, which will be automatically figured out, or we can explicitly state the raw base image that we want to utilize, like we did within the Docker, within our Docker file. So what I mean by that, if we open the Docker file, you can see that I said from Python 3.12.9-slim bookworm. I already specified and grabbed that base image, and in my Docker Compose file, what I did was I referred to it accordingly here by the Docker file in the build context, as we can see. So when I utilize image, then the image property, then whatever I put in right next to that was going to be the name of the Docker image. So the name that I called it. But what we can also do is explicitly here refer to a base image as well. So that's just something I want to mention just so that you're aware. So here we have image, and we're going to want to look for a Postgres database. So if we go to Docker Hub, we can search for Postgres, and we can select that option. Okay, and here we go. So again, good practice to choose a specific version here. So I'm going to choose just 17, and it's going to be coming from Postgres itself. So what I can do is head on over to Docker Compose, and here by image, what I can do is I can just say postgres : and then we're going to use 17. So that's the version that we're going to be utilizing, and coincidentally the name will also be Postgres 17, the name of the Docker image that we'll build. Then we want to specify the container name. So this is going to be the name of it. So container _ name. I'm going to call this Postgres-DB as the container name. Then I want to always restart the database automatically if it stops. So I'm going to say restart always. And this also pertains to if it has been stopped with Docker Desktop. Then I want to define the environment. So I'm going to say environment, : enter. Then I want to add in a space here. And then what I'm going to do is specify the database name, the username, and the password. So I'll say postgres _user, : and here I'm going to just say my _user. Then we'll have the password. So I'll have postgres _ and I'll say password. And here I'll say my _password. Then I'll have postgres _ and we'll have DB, so the database. Here I'm going to say my _database. So you can define it how you would like to. So we've got all of that set. Okay, great. Now we need to specify the port. So that's going to be in line with the environment. So here we can just make sure we're in line and say ports, : and we can just add a space, space, and here in quotes we want to map it on port 5432, which is the default Postgres port, and map it to 5432 on the host and the container port. So that's going to expose the Postgres database on the necessary port. Great, so we've got that now set up as it should be. Right, now the next thing that we're going to want to do is open up our settings.py file. And as you can see, we're using a default SQLite database. I'm going to comment this out. Okay, and we can utilize that structure. So I'm going to copy that, paste it here. And the next thing that you want to do is you want to install the psycopg2 binary package. And this is going to allow us to utilize and connect Postgres databases within a Python-based application, in other words, our Django application. So you want to make sure that you run the following, which is pip install psycopg2-binary. And you want to make sure you install that in your virtual environment. Okay, let's just be a little bit patient here. Okay, as you can see, I've already installed it, but make sure you've installed this. And you want to add this to your requirements.txt file. So you can just say pip freeze > requirements.txt. There we go. So you can just confirm that that's in there. So if we open up requirements.txt, you should now see that you have psycopg2 binary in there. Right, anyway, let's continue with our database. So the engine now. So now that we're using a Postgres database, you want to remove the .sqlite part, and you want to say postgresql. Okay, then the name here. So we can just remove this base directory. And we want to add here the name of our database. So we can go to Docker Compose. And we can see that the name is my_database. So we will just replace this here with my database. Okay, then of course we're going to have a username. So we can say user : colon, and we can look here, and the user is going to be my_user. Paste that in. Right, next, we're going to have the password. So we can just say password, colon, and we can just copy the value there. Go, and we'll have host. Now the host is going to pertain to whatever you name the service here. So the service here is called DB, and that's going to be the value for the database here. And finally, you'll want to specify the port. So that is going to be 5432. Right, perfect. So there we have it. There we have our database credentials in place for our Postgres database. Right, so make sure that you've got that defined and you've got that set up. So that's essentially what we need here. And of course, here at the end, what we're doing is we're just exposing the Postgres database on port 5432. Right, so make sure that you have that in place. So we've got those settings defined. And now what we can do is actually go on ahead and test the process out. Right, now the next thing that we need to do is to create our containers and everything. So we can go back to Docker Compose, and we now want to go ahead and create everything. So what I want to do is just add a space here, so we have a clear distinction between our services. So let's just do that. So we have our Django web application, we have our Postgres database, and let's go ahead and test this out. So what I'm going to do now is I'm going to head on over to the command prompt, and I'm going to say docker compose up -d for detached, and then I want to add in --build. Right, so as we can see, it's going to pull our database, as we can see here. Okay, and it's going to show all of the threads of the processes that are occurring, and it's going to be quite a while. So after this has been completed, we can go and run through it. All right, so we can see the process was completed. So to start from the top here, as we can see, our database threads here were in place and set up. So this is our Postgres image here that was pulled. We can also see our Docker file instructions were set up. So as you can see, when we got the base Python file, also our instructions in terms of setting the work directory, obtaining the requirements.txt file, copying it over, installing it, and copying and setting everything up accordingly with our project. And that image was exported as well. As for the bottom, we can see that our application container, known as Docker container, and our Postgres database container was created with the default network, and the app itself was built. Right, perfect. So we can clear that up, and for observation, we can navigate to Docker desktop. And as you can see from this Docker project that we now have our app container known as Docker container that pertains to Docker image, and we can see we have a Postgres container as well accordingly. We can also see that both of those images are in use. So we can see that Postgres image that we obtained and that Docker image that we set up custom. All right, great. So what we can do now is navigate to our command prompt, and now we want to make our migrations. Now remember, our Postgres database is running within our container, so we need to ensure that we enter in to our Django application, which is transformed as a container known as Docker container, to execute the python manage.py migrate command and superuser command, etc. It needs to be done within this Docker environment. So we can open this up, and we're going to use a special command. So it's going to be docker, then exec. Now this is essentially going to allow us to run a command within a running container. Now, unlike docker run, which starts a new container, exec executes the command inside an existing container that is already running. Okay. Then you want to add in the flag -it. Now the I stands for interactive. This helps to keep the session open so we can interact with the process. And the -t, it stands for TTY, so that's going to allocate a terminal so we can see our output properly. So that is the whole process. So the whole idea of these two parts together is to allow us to interact with the process in our container. All right, next thing we need to do is refer to the Docker container where our Django application is within, and that is called Docker container. So we can just say docker-container. And the last thing that you want to do is actually just go on ahead and run your regular commands. So python manage.py migrate. right? And that's going to make our migrations for our Postgres database. There we go, it's been migrated, perfect. And the next thing you want to do is reinstantiate that command, but you just want to remove the migrate part and say create super user. Okay, and we can just say Arno-admin1, skip the email, enter in a password. And there we go. Now we can actually test this process. So remember that this is a running Postgres, how can I say, database within the container. So we're not going to be able to actually access this within our regular Django application. So it's going to be available via the containerized one. So if I head on over to my application, it's only going to be usable within my Dockerized application here together. Okay, so here we are. And you just want to say admin. And now you can put in those credentials that you had. And then you can log in. And there we go. We can go to users to confirm. And there we have it, Arno-admin1. There we have it. So that is how you can utilize a Postgres database and to go ahead and transform it to be utilized as a container and to put that in and connect it with your containerized Django application itself. All right. So do keep in mind this is not going to work with your normal application, only within your Dockerized one, which you have stipulated right here. According to the following endpoint, it will work for that. Okay, so that is just something else I wanted to teach you. So that is just important to keep that in mind. Now, in terms of moving to a production-based environment, it is a best practice, should I say, to utilize the Postgres databases externally from the cloud providers that are out there. So if you're using Railway or using Render, it's best to rather utilize those ones instead of a Postgres container like here. Now, this is very suitable for testing and development, very much so. But if you are moving into production, it would be best to utilize those external ones for those cloud services. So the whole process and what I've shown is a little bit different in that regard, but it's important to know this for clarity. And technically you can use this in production, but it's not advised. So just a little bit of advice and output from myself in any case. All right. Now, the thing that I want to explain now is data persistence. So as you can see, if we head on back to Docker Compose, you can see that we had a volume here that was attached for our application itself. So our Docker application that we use for our Django application. Now, if you go to volumes, you'll notice that that exists here, and that's going to allow us to persist any data in terms of changes to templates, views.py, forms.py, anything in the current directory of our Django project. But you'll notice that we didn't go ahead and set this up for our database, which means that if we were to delete our database, so our container, for example, and the associated image, what's going to happen is that data is then going to be lost. So this can be done just by a simple deletion of our containers. Now, if you were to stop your containers or to pause them or anything of the like, that data is still going to be persisted. Okay, so let me show you what I mean by that. So if I were to select all the containers and just say stop. Okay. And let me go ahead and start them up again. Okay. If you head on over to your container and go to the admin, okay, it will just take a moment. Let's just refresh. There we go. Okay, sometimes it just takes a moment to start up. You then want to put in those credentials that you had earlier on again. And now when you log in, you'll be able to log in fine. Okay. So the data is still going to persist if you were to restart. Let me just go back to admin. Okay, now if I were, however, to go to containers and instead of going ahead and how can I say stopping them, let's say I were to delete them. Okay, all of that data is now lost. Okay, so it's not going to persist. So if I were to set up our container up again, you're going to see it's going to prompt me to go on ahead and re-migrate all of the files again and the super user and everything like that. So let me show you what I mean by that. So now if I were to, okay, let's see, I have my images. I can just simply say docker compose and up -d. Okay, I just need to recreate the containers. There we go. Okay, so they're now recreated. Okay, and what I can do now is go on ahead and run the commands that we did before. So let's see where we have it. So there we have it. Now you're going to notice if I say migrate and it's already been migrated, it's essentially not going to prompt me to do it again. So if I say migrate, you're going to see it's going to do it all over again, and I have lost all of that data. So the data didn't persist. Now, this is where we can utilize a volume for our database so that that data is going to persist, even if I were to delete the container. Okay, so essentially now what we need to do is we need to delete everything here. Okay, so I know it's a lot of ins and outs, but this is how you'll really learn and understand the process properly. Images, volumes, and we can delete that. All right, so let's just clear the cache. Yes. And there we go. All right, so let's head on back. So here we have our database itself. And what we need to do is to ensure that we're able to store the database data persistently, we need to specify the following setting here. So just in line of environment, we can just say volumes. And you want to go to next line, space, dash, and you're going to say here, postgres underscore data, colon, /var/lib, and you're going to say /postgres SQL/data. And this line here is going to allow you to store your database data persistently. And what you want to do then is right here in the end, so in line of services, you want to go on ahead and specify volumes and add a space, and we're going to say postgres underscore data, colon. Okay, so that's going to define a volume to persist our Postgres data accordingly to prevent data loss. Now we have everything set here automatically for our volume for our app, so we're covered, but now we're going to set it for our Postgres data as well, so we don't have that data loss. All right, so once you've integrated that in, we can go ahead now and run the base command. So docker compose up -d build. All right, so let's run that. And let's be patient. All right, so everything was created, and now this time we can see we've got a special volume that's been created here, okay, that we have set up to be called as Postgres data and linked accordingly to what we specified earlier on. Great. Well done. So now we can see if we go to volumes that we have this volume set up here. Of course, we have our images and we have our containers set. Now what we can do is we can try this process again. So let's go to our command prompt, clear that up. And let's go ahead and run the execute command here. So exec, and then we want to base this to make our migration. So of course, this is going to be the first and only time we're going to run this migration. And then I'll just switch this for super user. Create super user. Okay, and I'm going to say Arno-admin, and I'm going to say 1. Enter in a password. And again, there we go. All right, so that's fine. Let's clear this up. Okay. All right, so we can now go on ahead and log in just for good measure. Okay, so we can just refresh this actually. Okay, and now we can enter those credentials just as a quick test. All right, and that's going to be fine. Yep. Okay, let's go back. All right. And now, okay, we're going to delete the container. So this is the chest. So let's go ahead and select them, delete, delete forever. Okay. Now if we go to volumes, that volume is currently unactive. Okay, so we can see we still have this here and it's not going to go anywhere. We still have, of course, the images, but let's go ahead and rerun our containers. Okay, so we can just say docker compose up -d. That's all we need to say to get the containers back. There we go. Right, so our container is up and running. Now what you can do is try and log in with your credentials again. Right. All right, now if you log in, you'll see now you can log in perfectly fine. All right, and that is, of course, because of the fact that we have deleted our, how can I say, we have deleted our containers, but we ensured that we persisted that data within a volume so that we will have access to it, and now you can see it's in play. Now another cool thing that you can check here is if you were to run that command that we did earlier, so to run the migrations, you'll notice that we don't need to go on ahead and make all of those migrations. You can see it's already been performed because of the fact that we added in that volume. Okay, I know that was quite a little bit of back and forth, but this is how you learn things properly, by doing. Okay. So there we have it. Okay, so that is how you can ensure everything is in place. So now you have the understanding of the difference with the volumes, how they can be integrated and into place. So like I said before, this is a really good way for testing and local development. Can technically do this for production, but it can be very unsafe because of scaling, security, maintenance, etc. But it's just something very important to note when you're containerizing with Django. All right. So that is it. So let's go ahead now and delete our containers. We are then going to focus on the deployment preparation part next and get everything ready with what we need. Delete that. And we can delete that. Right, so we can now say docker system prune. Yes. And clear. Great. Okay, so that is that. Okay. All right, so we've got all of that into place, and that is how you can containerize a Postgres database and connect it and utilize it with your Django application. Right, now the next thing that we want to do is we want to set up our production Postgres database. So what we can do is we can utilize Render. So you can head on over to render.com, and all you want to do is get started for free and create your account. I'd recommend signing up with your GitHub account. It's going to make things a lot easier. So that's the next thing that you're going to want to do. So get started with Render and create your GitHub account. Okay, now after setting everything up, you'll then be redirected eventually to the Render dashboard right here. And what we can do is we can go ahead and create a Postgres database. So we can choose this option right here. Okay, then we want to give our database a name. So I'm going to call this production database. Okay, we can leave everything else here on the default here. And of course, you can select the version that you would like for Postgres. And here under instance type, you can use the free option that is available for you for testing out a Render Postgres database. And if you're happy with everything else, you can just confirm that it's free and create your database. Okay, so it's going to take some time for this database to be created. So all you're going to want to do now is be patient as it gets created. So here we have it. We can see that it will expire. So if you want to keep it available, you're going to need to upgrade to paid instance type. But it's the perfect use case just for testing and seeing everything get completed and everything like that. Okay, so it's going to be created. It's going to take some time. So all we want to do now is just be patient, and then we can continue once it's been created. All right, so let's continue. So you can now scroll down. You can see your database is now in the available state. And if we go to connections, we can see all of the relevant information is available for us. So now let's upgrade our database to a production database. And you can navigate now to your settings.py file. And this is perfectly suitable for local development, but now let's upgrade to production. So first of all, the name. So the database name will be right here. So next to database, that in. Okay, so now switch that around. Then we need the database user. So we can see the username is right here. Let's put that in. Okay, then we need the password. So the password will be right here. We can reveal it, copy it, and just adjust that. Right, then we need the host endpoint. So that is given by the external URL since our application is currently on our machine. So we can just copy the following. And usually you can utilize this with DJ database URL in a quicker fashion, but I'm just going to show you how you can do it in this manner. So you need to look for the endpoint. So first we need to remove what is at the end. We want to have the .com, and the endpoint is from DPG, okay, all the way to .com. So if you see something was a structure bearing the following, as you can see on my computer, that is roughly what your endpoint would look like, was the following structure. And then for the rest, with the @ symbol to the end there, you can just omit that. So this is going to be your host endpoint here as follows. Okay. Right, so make sure that you've utilized it from external database URL. We're then going to switch it out to internal once we have essentially deployed our Docker image. Okay, we've got the port here at 5432 as well. Now, a good test to see that we're connected is you can just say python manage.py migrate. Okay, so we can make those migrations. Okay, so this is a good indication that it has been set up as it should have been. So let's just give that a moment. All right, so we can see it's been migrated. Now we can create a super user. So we can say python manage.py create super user. Okay, I'll say arno-admin-prod. And we can enter in password. And again. Oh, there we go. Perfect. So we can see that was set up correctly as it should be. Right. Now we don't need those settings in our Docker Compose file anymore. So what we can do is this database part here, we can just remove this. Let me zoom out so I can see. Okay, so this is very useful for local and testing. But we can just take that out, and the volumes for the Postgres data. Okay, so we're essentially going to Dockerize our Django application as was mentioned. All right, great. So we've got that in place. So we've got our database setting in place and working. Great. Okay, right. So we've got that in place now. Okay, so I'd recommend that you just keep this tab open. And what I'm going to do is just duplicate this, close the following. And I'm going to return to the dashboard here because it's going to be important because we need to grab this internal database URL once we have deployed. Great. Okay, now the next thing that we're going to want to do is we're going to want to utilize white noise. Now, white noise is a package that we will use to serve our static assets. So any CSS, JavaScript, files that we may have for our application, all of the behind the scenes JS and CSS files for our Django admin that are default in place. Now, to set this up, we need to first of all install white noise. So I'll just zoom in here and we want to copy the following. Let's go to our terminal and you want to say pip install white noise. Okay. There we go. And in terms of the next step, we need to ensure that we add white noise to our middleware list above all of the other middleware apart from Django security middleware, which is right here. So we can go ahead and copy the middleware. Let's go to our application. Now, I also just want to mention before we carry on, make sure that your SQLite database is commented out and that your Postgres database is as is. Okay, so middleware. Here we have it. So we're looking for security, okay, and it needs to be above everything except that. So here we've got it set into place, so make sure that you have set that up. Next thing that we want to do is we need to ensure that we have the necessary caching support. But before we can do this, we need to make sure our static directories and such are in place as they should be. So in my current application, let's just close these files. As you can see, I don't have a static directory for my application, but let's go on ahead and assume that I did. So for clarity, I'm going to say new folder and I'll call this static, just for peace of mind so you can get the structure. So let's say you have a static folder and you have your CSS and JavaScript files in there. Typically what you would do in your settings.py file is you would scroll down to static URL here and you would just set up, first of all, your static dirs. So you would typically say static files underscore dirs equals, and you're going to usually base that on base underscore dir / static. So that's just going to tell Django, hey, look at my base directory, okay, for my static files here named static. So that's just going to allow you to utilize them. So that's what you would do if you have your static files here in place. Now, the next thing that you'll do is define static root. Okay, so to do so, you would say static underscore root equals, and you'll say base underscore dir / and then static file. So in this line of code, what you're doing essentially is you're telling Django in the base directory, create a folder or directory known as static files dirs, and this is going to house all of our static files, all of the custom static files that have been defined by this line of code. So any custom static files you may have, and all of the behind the scenes static files in one folder. That includes the Django admin static files that we don't work with, that we all have, irrespective of if we have a application that has the necessary files or not. Okay. And then what you can do is to ensure we have caching support and compression, we can add in storages here, and that's going to allow us to serve these files accordingly. So we can copy that and we can just put this here, and you just want to remove those 3 dots. So now what's going to happen is once we've gone ahead and ran a python manage.py collect static, it's going to White Noise is going to allow us to look into our static files directory and ensure that we have compression support for those static files so they can be served. So make sure that you've got the following in place here. So just want to tighten this up so you can see. All right. And then what we can do is just say python manage.py collect static. And that's going to collect all of our static files and house it into the static files directory that we specified. Okay, so we want to do that. There we go. So we can see that that has been copied. And now if you have a look here at static files, you can now see that we have, you'll see all of your static files here that you have the custom ones. And you're also going to see the admin one, which you can see I have here, such as CSS, images, JS, and very important, make sure that you have this static files.json file. This is going to ensure that you have white noise set up as it should be, and that you'll have compression support. Okay, great. So that is it for the static assets. Okay, perfect. All right, great. Now the next thing. Next thing that you want to do is you want to install GUnicorn. Now this is going to allow us to utilize GUnicorn as an interface for communication to bridge the connection between our Django application and the render servers. So we need to ensure that we install this. So let's clear that up. And you can say pip install GUnicorn. Okay, perfect. And while we add it, we can just add all of these packages that we installed to our requirements.txt file. So you can say pip freeze greater than requirements.txt. There we go. And we can navigate back. And we can now see in our requirements.txt file, we have GUnicorn, PsychoPG2, and we have white noise. All right, so make sure with your packages that you keep it quite minimal and that you don't go overboard on them. Okay. All right, so we've got that in place. Right, the next thing. Next thing you want to do is you want to make sure that you have a GitHub account. So make sure that you've created one and that you are on the dashboard and logged in, and that you also have set up Git on your machine. Now, of course, I do have a video tutorial on Git and GitHub on just getting started and setting them up, especially Git. So GitHub will be quite simple. You just go to github.com and then create your account. But I have some more information in a video on that as well, which I'll put in the description below. So you can just go ahead and have a look into setting up GitHub, or Git should I rather say, and just organizing them. So make sure that you have them open, so you have GitHub and you're on your dashboard, and that you have Git installed on your system. Okay, very important. Okay, let's continue. Now, the next thing I want to do is prepare for deployment. So I'll go to settings.py, and I'm going to go to the chop. All right, so first things first, let's remove what we have here. I want to set up my environment variables. So what I'm going to do is I'm just going to minimize everything and open up my file. Okay, and here I'm going to set up the environment variable. So I'm going to say import OS. I'm going to utilize OS module. And here I have my secret key. So I'm going to copy that associated value. And I'm going to actually let's paste this whole line in so we can see it. Okay, and I'm going to save this just to my local machine here, just so I can reference it so we can later go on ahead and add this directly to our cloud service provider. Okay, and then you can remove the value, and you can say os.environ.get, and the environment variable that you will set, okay, needs to match. So here I'm going to say secret_key, and this will match in the cloud service provider. So in render side, I'll explain more on that. Then for debug, we're going to say false. Okay, allowed host, for the time being, we can add in star just for all connections for now. And you also want to set up your CSRF trusted origins. So we want to say CSRF_trusted_origins equals, and you want to comment that out for now. That's just going to ensure that we can make our post requests with ease, and that we don't have any kind of issues of the like in that. Now, what you can do in the meantime is you can just add in the schema for now. So the schema is going to be https://, and then we'll add in the necessity afterwards. So we can just comment that out now. Great. So we've got that set up. All right. And then we also have the database credentials. So I want to have name. Okay, and we'll have user, and we can just copy the whole lot. Okay, and we'll just adjust that. Okay, so we have that, and I'm just going to swap all of this out. So I'm going to say os.environ.get, and here I'll say name. That'll be pertaining to the database name. os.environ.get user, and then password os.environ.get password, and then we'll have host. Did I? Yeah, I got the host. .environ.get host. Right, there we go. So we have our environment variables configured and set and ready to go. So make sure that you've got that into place as follows. Okay. Right, next thing that we're going to do is head on over to our Docker file. And we're going to add in an extra command here. So what you want to do is you want to go on ahead and ensure that just after copy that you have run Python manage.py collect static, okay, --no input. So we don't need to explicitly go on ahead and say yes or why. That is the flag that we're adding at the end. So we want to collect our static files as well here when we are utilizing the Docker file to build the Docker image and such. All right. Okay, so we've got that set up as well. So make sure you've made the adjusted changes. So the important checklist here is to ensure the following: that you have configured and set up your static assets for production, so your static files, that you have made the necessary changes to your Docker Compose file, that you have set up your database, that you have configured your database, and that you have added the adjusted settings for preparation. Now, a final touch, which I would like to do here, is also with the naming conventions here. Okay, so what I'm going to do is I'm going to change the name here from docker-image to app image and app container, because remember we are containerizing and deploying our Django application here. Okay, that's quite clean. I'm quite happy with that. So just a final touch on that regard. All right, so the next thing that we're going to want to do is we're going to want to go on ahead and ensure that we have everything correctly in place for the next set of steps. So first of all, if we go to Dockerfile, I just want to set this to T. So I made a mistake there earlier on. So make sure it's collect static. Okay, great. All right, so now we want to head on over to our GitHub dashboard, and you want to click on your profile picture, to which you want to scroll down and go to settings. After which on the left hand side, you want to scroll down and go to developer settings. Then you want to select personal access tokens, choose the classic token. Then you can generate a new token and choose classic again. And this is going to be focused on our Docker image permissions. PAT personal access token, you can set the expiration as you so desire. And then we want to select the scope, so the permission access. So we want to be able to write packages that will automatically say read, and we want to delete packages. So essentially, we'll be able to upload, download, and delete packages, i.e. Docker images, from and to the GitHub package registry. Then you can scroll down and say generate token. Now, this will only be available to you once, so you want to copy that and save it somewhere safe. There we go. And we can close this up now. Let's navigate back to our homepage. Right. Okay, so the next thing I want to mention is in regards to the way of building a Docker image. Now, originally I was thinking of utilizing Docker Compose build, which is something we can use, but I want to keep it a little bit more straightforward for deployment and just keep it a little simpler. So what we're going to do is we're going to ensure that we add Docker Compose to our dockerignore file. So I'll have docker-compose.yaml. So make sure you add that in. Now, something else that I want to mention is while the Docker file prefix is correct, there are certain platforms that explicitly want you to add the uppercase to the D for the Docker file. And such places include Render. So I just want to right click on my Docker file and rename it as capital D for Docker file. And then you want to go to Docker file and you just want to set that as the capital D there. So just a small thing just to keep in mind just for compatibility on Render. Okay, there we have it. Right, now another thing I also want to mention in terms of getting everything up and running is our requirements.txt file. Now, we did install gUnicorn. Now, I believe there are sometimes updates that are made to these cloud service providers. And from my understanding in the latest setup of Render, that it doesn't require a start command. However, if you are deploying to Railway, it does have a requirement for a start command. Now, I don't know if Render is going to bring that back at any point. So use this as good measure for your gUnicorn library and package for your start command. So I'm going to keep it on in case there has been a change to Render where we need to put a start command in, but it might not be the case from what I last saw. But just keep that in mind. It's just a little bit of information on that. Okay, now building our Docker image. So first we need to go to our command prompt and we need to log into GitHub Container Registry. So you need to say docker login and we want to say cr.io, and then we want to use the flag username -- username, and that's going to be our GitHub username. which we can copy. Then the flag -- password, and that's going to be your personal access token, and that will log you in. Perfect. Now we want to build our Docker image, so we're going to use our regular Docker file and say docker build -t, and we're going to tag very specifically, so it needs to be ghcr.io/ and then your username, so you can just copy the following. Now remember, it is case sensitive, so if you have capitals like I do, you just want to lower them. Then at the end, you want to add in the / and then the name of your Docker image. I'm going to call it app-image. And then you want to add the context at the end, so you can add just a dot. And that's going to build your Docker image. All right, there we have it. So it's going to take some time, and once it's been completed, we'll head on to the Docker desktop UI, and then we'll see it and go from there. All right, so as we can see, our Docker image was built, so we can clear this up. And now if we go to Docker desktop, there we have it. Okay, now the next thing we want to do is we want to push this Docker image to GitHub Container Registry. So we need to refer to the name here. So we can click on that, and you can just copy what's up here. Let's go back, and now you want to say docker push, and then you just want to paste in the following. So docker -image here was the name. Let's put in, we had latest as well, that's the full name. Let's check. Okay, it's gonna have the tag. We don't need the tag actually. Just wanted to check it wasn't part of it. All right, let's push that now to our repository. Okay, there we go. And now we can navigate to the GitHub dashboard, and you want to go now to your profile. We're already here. Now you can go to packages, and there is our repository as it should be. So it's called app image. That's our Docker image. And there we have it. So voila, that's how we can go ahead and push our Docker image to the GitHub Container Registry. So the repository, you could say, for working with Docker images in GitHub itself. All right. Perfect. Now, the next thing that we're going to want to do is we're going to want to ensure that we can access this in Render. So it's very simple. So what we can do is we can go on ahead and go to the Render dashboard, and we're going to say add new. You want to say web service. Okay. Now, if you wanted, you could technically go on ahead and upload your project as is without utilizing the existing image. You can technically upload your project as is, and you would need to utilize Git for that. So we just really needed the GitHub, but you can use Git, and then automatically if you connect your GitHub, then what would happen is, as long as your Docker file is in the correct directory and you're pointing everything, Render will be able to create your Docker image for you. But what we're going to do is we're going to use the existing image that we have built, okay? And we have received a path to our Docker image itself, okay? So what we can essentially do is we can refer to the installation here accordingly. So we can copy this command here, and we can just go on ahead and paste that particular URL. And you can see here that no public image found. It looks like you may be using a private image. So in this case, you need to make sure that your image is public so that you can utilize it. So what you're going to want to do is you're going to want to head on back, and here by image, you want to go to package settings, and you want to change the visibility here to public. Just put in your image name. Okay, and if you say change visibility again, it should, oh, it seems like it didn't change that. Okay, understand. And that should do it. Okay, why does it stay? Okay, maybe I did change it accidentally. Maybe I'm just confusing myself. App. Okay, public, sorry. I was just changing it twice for some reason. Okay, that's good. All right, so we have that set. So if we go back, we can just paste in this installation here. And there we go, it picks it up. Great, you can also set in credentials as well if you're dealing with a private one, so that will take some extra steps. So you can now say connect. Okay, you can give your app a name here. I'm just going to call mine web app 1. Okay, in our case here, we don't need any of the run commands, so luckily for us. So we can say free. And now our environment variables. So I'm going to have secret key. Now that's going to pertain to the value that I set in my settings.py file. As you can see here, we have secret key. Okay, and that is the value that is looked for in the cloud service provider that you're utilizing. So here we have secret key, and then we just put in the associated value. So that's going to be whatever you have within quotes. So here I'll have the following. Then I'll have name. The reason it auto completes for me is because I just tested it earlier on. And we have name, user, and these environment variables here are pertaining now to the database itself here with name, user, password, etc. Password. And host. Now for the host, remember, this is why we kept our production database option open here. And we can scroll down, and here by the internal database URL, you can copy that. And you want to paste that in, and then we just want to adjust. We just need the endpoint, so we can remove everything before that @ symbol. Then remove that symbol, and this is what we need as the internal database URL. Then we can go back and paste that in. Right, so there we have it. There are our environment variables set up accordingly. Right, so make sure you set that up. You've chosen the free option, and you've got that all configured. So now we can say deploy web service. That's that. There we have it. Web app 1 is in place. So here are the logs, so you can see all the information of the server starting and the like here. So let's just give it some time, and once it's been deployed, we can go ahead and access our application. All right, so welcome back. So we can see our server started and is also live. We can see it's live, green, that's good. Now here is our URL, so our domain name. Let's right click, open that in a new tab. And there we are. So very well done on deploying your Django application as a Docker image and running that on Render. So very well done. All right, so here we have it. Everything's in place. Now we can check our static files. Let's go to admin as a good test. So we can put /admin, and here we can see our static files are in place. Now you can right click, say view page source, and there we go. We can see we've got cache busting in place here for white noise, and we are good to go. Now we won't be able to make post requests because we need to set up our CSRF trusted origin, but this is good for updates to our code base. But in any case, there you have it. So well done. Now, this next part is going to be on updating and how we can actually make use of the post requests on our website. So it is mandatory to know how we can update this. Now, there's many ways you can do this. You can also utilize GitHub Actions with the certain set of code that you are utilizing, but I'm going to keep it rather simple for our case. So we can go to our application, and here by allowed hosts, okay, we simply just want to copy that URL, and here we want to paste it in, but we want to omit the HTTPS schema and just have the domain name.com as the allowed host. Then we can uncomment this CSRF trusted origin, and then what we can do is, let's just recopy that URL. We can put that full one in, make sure you don't have a / at the end, and you want to make sure you have this in place for your trust origin. That will allow you to make post requests. Just make sure that you remove the Java part there. So there we have HTTPS and www. dot. Okay, I think it has it. No, it doesn't. Okay, this one does not have that. Okay, that's fine. So https:// that's fine. That's the schema you need. So the HTTPS part is important for your trusted origins, and allowed host, you just want to put in the raw domain.com there at the end. Right. Okay, so here, as you can see, we have our image. Now, if we go back, we can see if we click on manual deploy on this dropdown, deploy latest reference. So what we're going to do is we're going to do the whole process here. So go to your command prompt, let's clear this up. And we want to just use our upper arrow key to see what we used to build last time. So we're going to rebuild our Docker image. Okay, so it won't take too much because it won't take too long because it's already been cached. So it's not going to take as long as it usually would. So it's going to just rebuild. There we go. And now we can use that command from before, docker push, and we can push that. Okay, a lot of the layers will exist, and then it's going to push the rest. There we go, it has been pushed for us. There we have it. So make sure you've gone ahead and pushed all of that. Right, now we can go to manual deploy and say deploy latest reference. Okay, so that's going to get our update on the latest reference that we have set up. So that will be based on what we have set up here in accordance. So if I refresh this, I can see it was last published a minute ago. So that was the update that was sent through. So now it's going to grab that update that I have. And now you'll notice I'll be able to make my post requests effectively. So let's just wait for that. And we can see it's now live. So what I'd recommend is you just wait a few moments before testing it out. So what I'm going to do now is I'm going to go on ahead and reopen this link. Right now, if I go to admin, I should now be able to log in with that credential that I made earlier on when I created a super user. So now let's go ahead and test this out. Right, now let's log in. And there we go. We can go to users and we can see everything is as it was. So there is that user that we created previously. Okay, so there is everything in place. Now let's say you want to make an update here. So I didn't do anything noticeable here on the home page. We can also go ahead and update that. So what I can do now, just as a simple test, is just register a user. So I'll say test user1, test user1@mail.com, password. Okay, test user1. Okay, it's going to register there we go. And log in. There we are. So all of our general functionality is working just as it should. So very well done. That is it. That is how we can now also make updates to our Docker image. You can see it's very seamless, a very few commands that you have to do, and it's done for you. But like I said, you can automate this a bit better with GitHub Actions. However, this is on an existing image. So there is a way around this, I believe, but that is the simplest way in which you can get everything updated and started. Now, you didn't see any noticeable update here. So what I want to do is change something drastically here so you can see it. So I'm going to remove everything down here. So if I go to my application, templates, so this part here, I'm going to remove all of that. So that's going to be removed. So now if I were to build and obtain my latest Docker image reference, this will be gone. And you're going to see that noticeably in the update. So one more time, Docker build. It will be very fast. Okay, Docker push. So not even a minute. There we go. That will have been collected here. So if I refresh, less than a minute ago. And now if I were to say deploy latest reference, we can now see that it goes ahead and does just as it should. Right, perfect. There we have it. So that's going to update itself. So let's give it some time. All right, so we can see it's been set up. Great. Now if I were to open this up, there we have it. We can see that update has been in effect. All right, so there you have it. That is how you can essentially go on ahead and Dockerize your Django application or containerize it, and also to deploy it. All right, so we have that all done and in place. Right, now the next thing I want to show you is a security measure. So let's head on back to settings here. And we didn't specify any sort of credential, as you can see here. But let's go ahead and secure this. So what I'm going to do is here by the image here, I want to go to package settings. And what you can do is change this visibility to private. Set the app image. Okay, we can see it's now in the private stage. Okay, there we go. So now if I head on back to where we were, we can say edit now. And you're going to see it says no public image found. It looks like you may be using a private image. Please add a credentials to check the image URL for mistakes. So what we can do is add a credential. Okay, and we can call this Docker image creds. The registry, this is going to be from GitHub. So from GitHub Container Registry. Okay, we created that personal access token with the required read packages permission. That's what we did earlier on. Now we can just add in our username. So we are, who are we? Okay, and add that in. Then that personal access token that you created earlier on, and add that in. And now you can just say add credential. Now we were able to authorize access to this image with a selected credential. Save your changes. And we're going to see it will now start that service again. So now we want to see if it gets that particular image now. So we should be okay. So let's just give it a moment or so. And that's just a safer way to protect your images by utilizing credentials. Okay. Now, of course, you are adding in your environment variables to your to render directory, so there isn't an immediate issue, but it's best practice to keep things secure if there's opportunity to do so. There we go. Let's open this up. And there we have it. Okay. Now, another thing I just want to mention is, let's just double check. Okay, yeah, it was using the right one. So just remember that address may change. Okay, so there we have it. We're good to go. We've got everything secured now and in place. All right, guys, so that is essentially it on how we can set everything up. Just an extra thing I wanted to mention, an extra step there that we can set up. So that is it. That is how we can containerize our Django applications and also to deploy them. The last thing I want to do is just show you how you can clean your resources out. So here we have our web service, web app. You can go to settings, scroll down, and say delete web service. And delete that. There we go. Now for the database, you can just head on back and say delete database. Type in that command and delete it. There we have it. All right, so that is it. That is all. As always, guys, I just want to say thank you for the support. It is deeply appreciated. And until next time, goodbye.